Okay, I guess we're going to do a few problems. We're going to do a few problems on the from the homework. So let's just do, I think, problem number 11 first. So if we basically implicit differentiation, it's not hard, but it's different. So we got to do things a little different. And sometimes we have to do a combination of everything that we've learned up to this point, which is good because it gives us practice and prepares us for the final test. But not so good because it's hard because we're just kind of getting the hang of how to do this sort of thing. So we have an equation here. This is a circle. And the radius of the circle is the square root of 13. So I'm going to graph this. So we're going to do, let me graph this. And the reason I'm graphing this is because the textbook wants us to find the tangent line at the point 3, 4. So if you go over 3 and up 4, this point here exists on the line. Do you guys see that, 3, 4? And so what they want us to do is they want us to find the tangent line there. Is the tangent line going to be positive or negative? Negative, or the slope, I should say. The slope of the tangent line will be negative, right? So now in order to do that, we have to do it implicitly, which isn't always the most favorite thing to do. But so how do I do that? That's really kind of confusing. Well, we could use the power rule or we could expand it. Truthfully, I don't know if one is easier than the other. If we do the power rule, for example, if I were to apply the power rule, we would almost kind of treat this like u squared plus v squared equals 13, right? And then we got to remember that with the y, we've got to tack on the dy dx business, right? So how would that look? What would that look like? Well, the power rule would be is that we toss the 2 to the front. So I've got 2 times x minus 1. And that gets dropped down a power, so it'd be to the first power. Then we tack on the derivative of the stuff on the inside. So what's the derivative of x minus 1? Just 1. Plus, and then we toss the 2 to the front, so we would say 2, right, times the stuff on the inside times the derivative. But then what do we tack on in the end?
0.
Dy dx. And then over here, what's the derivative of 13?
0.
0. All right. I'm going to change markers so you can see it a little better. So now if I push this through, I get 2x minus 2 plus, well, I'm not going to, well, yeah, let's push it through. So I get, I have to be careful. I'm hesitating or pausing here because what I'm thinking to myself, guys, is like, if I push that all the way through and distribute the dy dx, is that helpful, or can I leave it factored, or, you know? So what I'm going to do is I'm just going to do this 2y minus 2 business and then leave the dy dx out here, which I can do. Because I just have to factor it out anyways, and that's equal to 0. So now if I subtract the stuff from both sides, I get 2y minus 2 dy dx is equal to, and then it's just the negative of those, minus 2x plus 2. Because I'm going to subtract both those and toss them to the other side of the equal sign. Yeah? Alright, so now if I divide both sides by 2y minus 2 and divide both sides by 2y minus 2, and about halfway through the problem I realized I probably didn't need to push that 2 through. Do you guys see why?
It's going to be x.
Because, yeah, I could factor it out at the end. So if I factor out my 2, I get negative x plus 1, and then over here if I factor out a 2, I get y minus 1. Right? And these kind of go away, right? So there's my dy dx. Now what I'm looking for is the slope. It doesn't ask me to write the tangent line. We'll do it anyway so you guys can see the whole thing coming, you know, I want to show you guys where this is going. What do I do next?
Plug in the point.
Yeah, plug in the point. So I've got an x and a y, and we're just going to plug that in. So I've got negative 3 plus 1 all over 4 minus 1. Negative 3 plus 1 is negative 2. 4 minus 1 is 3. So then my slope is negative 2/3. So now if I wanted to write the tangent line for that, I would say y is equal to negative 2/3 times x minus the x value, which is 3, plus the y value, which is 4. When I push that through, I get negative 2/3 x, and then I get a positive, the 3's cancel, 2 plus 4, or y equals negative 2/3 x plus 6. Okay? So now what I'm going to do is I'm going to graph that and see if that works. Does it work? Cross is right there. That's the tangent line. And that's it. Any questions?